Hi, well, it's really wonderful to be here. Thank you so much for putting on this great meeting. I thought that given this is a new initiative for us and a new partnership with you, that it would be great to be here in person for at least a part of the meeting and hear firsthand what's going on. And I really appreciate all of Jennifer's comments and the welcome that we've received to partner with all of you and with NIDCD in this initiative. So I came to NIH about 6 years ago, and I'm an otolaryngologist, head and neck surgeon. My specialty is in ear surgery and in taking care of people with hearing and balance disorders. And so I come to this with an understanding of how little we actually know about the etiology of many of the disorders of the inner ear that we treat, and a understanding that it is human tissue that will probably get us to the place where we understand these disorders better and can offer more targeted treatments. So next slide, please. So human temporal bone tissue has been studied since the 1700s, and it's been studied using the techniques of the time, which have improved over time, but the field was stagnant, I would say maybe in the 1960s and 70s, not very much happened. And so there was this feeling that the tissue really wasn't very valuable. It was devalued and not funded very well by NIDCD that time, but with newer techniques and newer imaging capabilities and the ability to combine all of this information in big data sets, we became increasingly convinced that this information was going to be critically important to move us forward and be able to deliver better care to our patients. And so hearing imbalance is one of 7 mission areas that we focus on at NIDCD. The other areas are taste, smell, voice, speech, and language. But this initiative is really focused, at least for the time being, on hearing imbalance. And the function is contained within the inner ear. You can see the little spinning skull there. And the inner ear is contained very deep within the skull, about 1/3 of the way into the skull on either side of the head, and it's encased in the petrous bone, which is the densest bone in the body. And so we're very limited in what we can do in a living person to examine the inner ear. Imaging is improving. You can see that beautiful synchrotron image of the cochlea on the right there. And we're also looking to develop better imaging techniques with higher Tesla MRI imaging, with OCT and other new capabilities. But for the time being, when a patient comes into the clinic, we can look in their ear canal, which doesn't visualize their inner ear at all, and we can get an audiogram, and we can get their history, and that is really just about it. So we're looking to be able to use this really, really valuable human temporal bone tissue from donors to be able to combine that with their medical records that are becoming increasingly good in reflecting what's going on in terms of the patient's history, the other medical conditions that might affect their hearing and balance function, and their audiogram, which reflects some measure of their hearing, and be able to look at these big data sets and actually make some conclusions about the etiology of inner ear disorders that will allow us to develop better treatments. Next slide. So the tissue that we have is postmortem tissue, and for many years NIDCD funded an extramural lab to have a human temporal bone registry. And so that is what we've had for many, many years. And one of the goals that I and the other program officers that lead this program, and I'll acknowledge them at the end, we've had this dream that we would bring this program in-house and be able to direct it the way that we wanted to do, put more resources into it, and use the other resources across NIH to help to complement this program. So this is really a dream come true for all of us, so that we will now have high quality postmortem tissue combined with medical records. The postmortem tissue is digitized and placed in a database so that it can be readily accessible to many different labs. And next slide. So one of the best advances that we were able to make is to partner with an NIH-funded program, and I've written it down here because I can't remember what it's called, but it's the Human Tissues and Organs for Research Resource within NDRI, which is the National Disease Research Interchange. So this was a fantastic discovery. This is a not-for-profit organization that has over 40 years of experience in providing human organs and tissue from a diverse pool of donors to support advancement of biomedical research. And so this is just a fabulous partner for us. And one of the fantastic things about this is that they're sourcing lots of different kinds of tissue, including brain. So the brain is a hearing organ. You know, the ear, auditory nerve, the vestibular nerve project to the brain, and we have auditory pathways throughout the brain. So to be able to source human temporal bones with the partnered brain tissue, I think will be a huge advance. And so the components of the temporal bone research program that we have are to support this donor program, then to support a network of laboratories. So when the human temporal bones are harvested and combined with the medical records, that information is forwarded to one of our 7 national labs across the country. That information is then processed and digitized, and it'll be placed into FaceBase and available for all kinds of analysis. Some of the tissue is also reserved so that we can provide it to investigators who are interested in doing special kinds of immunostaining, for example, and fluoroscopic evaluation, so that there's really an infinite amount of information that can be obtained from this highly valuable tissue. And next slide, please. So these are the near-term goals for our collaboration with FaceBase over the next year. Right now, we're working on infrastructure setup and data migration. So we have a couple of different databases that will be migrated to FaceBase over time. Second phase is image data acquisition and web portal development so that the information can be searched and downloaded by investigators all over the country and potentially all over the world. And then further enhancements and data processing capabilities with a formal rollout anticipated in about a year. So that's a really optimistic, I think, and doable timeline. We're really looking forward to having this accomplished over the next 12 months. Next slide. So some of the future goals that we have are to explore, as I think we've heard, we'll have all of these data in one place so we can explore overlaps between temporal bone structural abnormalities and craniofacial disorders. We can collect additional images, including new kinds of imaging data as they become available, and look at new ways of analyzing temporal bone tissue with new staining techniques and analysis techniques. Upload phenotypic data from both hearing and vestibular testing. So right now, we typically don't upload the vestibular testing, but that is a opportunity in the future. Of course, encourage AI and machine learning analysis of all of this information, which is the core of what FaceBase is about. And then syncing with other databases, such as some that we have in our own institute, including a platform called GEAR. Next slide. So many people to thank. This has been a really aggressive effort over the past 12 months to get this in place. And I want to particularly thank Dr. Susan Greguric, who has generously provided extremely necessary and valuable additional funding to make this all happen in the time frame that I've told you about. Our colleagues at NIDCR have been absolutely wonderful. I think Lou Wang presented at our council meeting about 1.5 years ago. At that time, we were thinking about a partnership, but really this didn't come to be until within the last 12 months. So this has been, as I said, a really fast effort. And was accomplished only because of the huge contributions of many, many people. I want to thank our PIs, Dr. Chai and Kesselman, who've been wonderful to work with, and our scientific program leads. Amy Paremba and Janet Sear have led this program for many, many years. I was an advisor on the advisory board when we had 4 labs and a annual meeting, and I became aware through those meetings how valuable this program is, and became determined when I became NIDCD director to expand it. And Amy and Janet have been champions all along the way. And we decided over a year ago that we needed a person in-house, a program officer who would lead the program. So spent many months recruiting Dr. Troy Hackett, who is an absolutely fantastic colleague. He has led this program for the last 12 months. Unfortunately, because he'd been with us for less than 12 months when some of the activity earlier this year took place, we lost him as a program officer, but we've been able to bring him back part-time, and he accomplishes a great deal in his 2 days a week. I suspect he spends much more than 2 days a week on the program, but he's been a champion and has been able to carry the program forward. And I think that's my last slide. Yes, okay, thank you.